What's up, everyone? This is LeetCode 31 and next permutation. Okay, you can read this here. I'm just gonna allow you to do that because I don't want to make this video too long. But basically, as you can see by once you read this part, we basically have right. We basically have to sort the permutations according to their lexicographical order, and whatever array we're given, right? We need to basically get the next largest or the next greater permutation. If there is no next greater permutation, we basically have to return the lowest possible order, sorted in ascending order. So to me, kind of like I said, I didn't say this yet, but this problem is really hard. A lot of people generally think this problem kind of sucks. It kind of seems like you just have to sort. You don't have to sort these by lexicographical order, but conceptually, the way you think about it is, you have it sorted in a lexicographical order, and you have to get in the container. Have to get the next one. That's going to be your output, right? If you're like here, the next one, there is no next one, right? So you'd have to return, basically loop around and get the lowest one, which would just be the reverse, right? Conceptually, you can kind of think of it like that. That's not how we're going to approach the problem necessarily, but like conceptually, you can think of it kind of like that. We have to do this in place and use constant extra memory, right? Okay. Now this problem does kind of suck. A lot of people usually think that, I don't know if I mean, it's not, it sucks in the sense that this problem is very hard to solve if you've never seen it before. It's just one of those. So, I mean, I don't know, like, unless you've done a lot of permutation problems, I don't know how you could come up with a solution to this problem. Honestly, it'd be very difficult, in my opinion. But, basically, you can have three cases, which is what I'm going to use to break this problem down for you, right? We can have an increasing order, right? Like, example 1, we're given 1, 2, 3, right? And we would really just swap like the last two values because that would be the next greater permutation. And we have decreasing order, in which case there is no greater permutation, right? Like 3, 2, 1, there is no next greater permutation. So we're basically just returning that reverse in that case. And then we could also have a mixed case, which is like it's ascending order and then it's descending, right? We go 1, 3, 4, 9, and then all of a sudden we have a 7 and a 5, right? So this is kind of more the bulk of this problem. How we're gonna basically derive an algorithm to basically solve this, and our algorithm will basically handle these cases as well. Okay, so it's, in some ways the solution's pretty, even though this problem does suck in many ways and people agree, I honestly think the solution to this problem is pretty cool because you can solve for this and this and this. I mean, with one algorithm, I don't know. I think it's pretty neat, right? So I just kind of broke these down into steps to try and explain how we're going to solve this. So formulaically, how we're going to handle this is we're basically going to always start from the right side, right? We're going to start from the right side of the array with a pointer. Now we're not going to set the pointer at the very last index. We're going to set it at the one before the last index because we're going to do this comparison here, which is nums of I and nums of I plus 1. So we don't want to start at the last index because we'd be out of bounds, right? So we're basically going to start at I of the last index minus 1, right? So it'd be right here. And what we're going to basically check if nums of I is less than nums of I plus 1. The reason is because when we're going from right to left, we should expect this to increase. Now, at the point where it decreases, right, that's basically what we can just call our pivot, and that's basically gonna be useful later on, okay? And I'll kind of explain this as we go, so it makes sense, okay? So we should be increasing, right? So we compare this 7 to this 5. 7 is not less than 5, so we move the pointer back and keep going. Is this 9 less than 7? No. Is this 4 less than 9? Yes, it is. Okay, so we found a case where nums of I is less than the I plus 1, right? And I guess more broadly, you can think of what we're asking is, yeah, well, never mind. We'll just stick to this just so I don't confuse you. So we found a case where 4 is less than 9, right? Well, 4 is less than 9 in this particular example, right? So we found a spot where this happened. Okay, now we need to set a different pointer, so we'll call it j. So I is right here at this 4. We're going to set a pointer at j, right? And we need to basically find a case where nums of j is greater than nums of I, right? And then we can do a swap. So when we set j at this 5, well, the i's here at this 4, right? So j at this 5 is going to swap with the 4, okay? Because when we find this, we're going to basically just do a swap with those values, okay? So the i's at the 4, we set j at the end of the, and again, the j is going to, like the i's is going to go from right to left, right? Until we satisfy this condition. Well, when we set the j here in this particular example, it already gets satisfied, right? Because 5 is bigger than 4. So we're going to do a swap. And then, by the way, the reason we have to do it like this is because we are finding the smallest permutation that is greater than the current one, right? So that's why we basically want to start from the right, because from right to left, it's we're handling the smallest numbers first, as we go from right to left. And that's why it's important, right? Because we want the smallest permutation that is greater than the current one. Okay, so after we do this swap with the 4 and the 5, right, we have something like this. Okay, now with this in mind, we want to reverse the array from I plus 1 until the end of the array. So we have this, right? Remember, the 4 and the 5 got swapped, so the I is right here at this 5. So we want to basically, this I'm highlighting here, we want to reverse this here, and we get 479, and that's our answer. Okay? And the neat part about this algorithm, it's going to handle the increasing order basically by swapping the last 2 values. It's going to handle the decreasing order by reversing the whole thing, and the mixed order case basically by formulaically and algorithmically handling what it needs to, as I just described up here. Okay. Like I said, this problem is not that pretty. It's very difficult to come up with on your own, the solution. And I'm going to show you this illustration because this helped me. This was in the solutions tab for the just written by LeetCode. They have a GIF here. I don't know if that's what you call it, GIF, whatever you pronounce it. Okay. So we're gonna find the first decreasing element, right? So, like I said, right? I don't know if I can pause this. No, I can't. But if I refresh it, it starts over. So from right to left, you see how it's increasing, right? We want to find the first case where the nums of I is less than nums of j, right? So here, this 4 is less than this 7 because this is I plus 1, right? So we found kind of, we can call it a pivot, whatever you want to call. People call it a pivot a lot in a lot of videos around the solution of this problem. So we can find this pivot. Okay, now we're going to set a j, we're going to find where the j, we're going to set a j at the end, and we're going to find where j is greater than I, okay? So our j should be this 5 here, okay? So we're going to find the 4, right? This is our pivot. So our I gets put here. The j, right, is going to be this 5, right? And I guess they went from left to right, but we're going right to left. I want to see what they did actually, because they went left to right. It's really interesting. Find a number just larger than 4, which would be the 5. And you see why they didn't take the 7 or the 6 is because, again, we want to find the smallest permutation, right? Right? Because if we're giving 1, 2, 3, for example, we don't want to return, anything bigger, right? We want to find the smallest permutation, which would be just the next one on the list of sorted container permutations, right? So that's why you don't want to take the 6 or the when we find this 4, that's why you don't want to take the 7 or the 6 for the j. You want to find the 5, right? That's why going from right to left is just easier. You don't have to add so you don't have to add logic for that. It's okay. So this is our I, right? Because nums of I is less than nums of I plus 1, right? So boom, that's where our j, they're doing from left to right, but we're going right to left. Either way, we find this 5, and then we swap the 5 and the 4. Now, this is where I is right here, right? This is where I is right here, right? So we're going to swap with this 5. After these get swapped, I plus 1, boom. So from here forward, we're going to reverse everything. All of this is going to get reversed. Just watch after we swap, right? So look at this. Reverse, boom. Simple, right? That's our solution, right? Yeah. If you're, I think that makes sense to me, to be honest, the solution I just described. to solve this problem. You're welcome to go on LeetCode and read other solutions if you want like a more mathematical or understanding approach, but like a lot of people say the same thing. If you know the solution already, it's medium. If you don't, it's much harder. Yeah, this problem is quite confusing, honestly. Like I don't know how you'd solve this in an interview if you haven't done this problem before, but there's not a lot of intuition behind this problem. I mean, I'm sure there's some mathematical reason for how this problem works, but it is, I don't know. You're welcome to look it up, but to me this makes sense. It's just for like algorithmically how you would solve this, but in terms of the intuition behind it, I don't know. I mean, yeah. See, they're describing this problem here, and they're kind of just describing what I described, but like the actual intuition of why the solution works. I mean, I haven't really seen much information about this. If your interviewer asks you that, I think they just hate you, to be honest. But yeah, that's how we're gonna solve the problem, and it will work for this and this. Okay, so now let's get into the code. Okay, so from here, remember for this example here, we're not setting I at the last index. We're gonna set it at the last, at the one before the last index. So we're gonna say length of nums. Instead of -1, we're gonna put -2, right? Because we're comparing nums of I to nums of I plus 1, and we don't want to go out of bounds. Okay, so we're gonna say while I is in bounds and nums of I is greater than or equal to nums of I plus 1, right? Basically, while we have no problems, we're just going to decrease the I. Okay. Now, if we're out of bounds, or sorry, if we're in bounds, because basically this while loop will break out once we're either out of bounds or when this condition is met. Basically, we'll break out of it, or when we're out of bounds. So if we're in bounds still, right? If I is greater than or equal to 0, what does that mean? It means we broke out of this while loop because we hit this condition here, so we found a pivot. In which case we need to set our j, right? So we're going to set our j to the very last index. So we're going to say length of nums -1. Okay. And we're going to say while nums of j, right? If that is less than nums of I, right? We're just going to decrease j. Remember, we're going to keep going because we need to find where nums of j is greater than nums of I. So we basically exit this while loop once we find this condition here that I'm highlighting with my mouse. And when we find that, remember, what do we need to do? We need to first swap these values, and then we need to reverse from where? From I plus 1, right? So I'm going to say self reverse nums of I plus 1. And we're going to need to implement these functions, right? Which is fine. We'll just do that really quick. So we have reverse. We know we don't need to return anything to this in the solution, because remember, this is done in place, right? So we're not actually returning anything, right? So let's just do the reverse function, right? So we have nums, we have a start point, which is what we're given, right? So we have ij, 1 is the start point, and 1 is basically where we're going to reverse from. So we're going to say while I is less than j, right? We're going to go up to the j. I'm going to say self.swap nums of I of j. Or we're going to invoke the swap function again here, but we're going to implement that below, okay? So we're going to basically swap I and j and then move the pointers, right? That's not too complicated. We're just doing swapping and moving our pointers along. And here we're going to say self nums. We have an I and a j, correct? Yep. So from here, we're going to say, we're going to have a temp variable. We'll call it nums of I, which is, the temp variable is nums of I, because we're going to override that, right? With j, nums of j. And we're going to say nums of j. Python does have some weird things where you can do like A of B is equal to B of A. To do a swap like that, I don't know, it's just very Pythonic, but we're just going to do it this way just because it's more formal, I guess. It's how you do it in most languages. So nums of I is equal to nums of j is equal to temp. Yep, so that's the swap. I think that's it, unless there's some sort of syntax error. There you go. Okay, so this will work. If you want to trace these, I don't want to make this video too long, but if you want to trace these examples like increasing order, decreasing order, and the mixed order to see that this will work for all of them. I mean, obviously it worked for all of them. I passed all the solutions even when I submitted, but it'll work for all of them, right? It just handles them a little bit differently, right? Depending on whether we're entering, whether we're actually even doing anything with the J or not, right? Like for example, I guess we can go over it really quickly. So if we have 1, 2, 3, well, we need to find in this formula where nums of I is less than nums of I plus 1. Well, that would be right here. Okay. Because 2 is less than 3. So then we set a pointer at the end of the array, we call it J, right? And that is greater than I, so we basically would do the swap. And we can't really reverse anything from I plus 1, so we would just get 1, 3, 2, and that would be our answer, right? Here, right, we never have any case where nums of I is less than nums of I plus 1, because this is not less than this, and this is not less than this, so our I actually goes out of bounds. So we break that as while loop because I is less than 0. If I is less than 0, nope. Or sorry, I is not greater than 0 at any point because I goes negative, right? Because this while loop just keeps going until I is less than 0. So we never enter any of this, so we have no swapping to do, and that we just have this reverse here that we use, and that's why when you have a case like that's just purely decreasing, that's why you reverse all of it and you get that, right? It's because you're only calling the reverse function and not any of this with the J stuff. And yeah, that's how you handle that. In the mixed case, I just showed you, right? That we just talked about it the whole time. But it also handles these other cases. So I hope that makes sense, and I'll see you in the next one. Peace out.